Alright, I took a little break between these two videos. I actually went out and played softball tonight, and if you're interested, which you're probably not, we won 14-4, and I pitched, did okay. But anyway, here we go. Let's do the next problem. Same deal. Pretty much everything's the same except for one thing. That really changes this quite a bit, actually. Alright, and it's continuously. And we have two equations right here. This is when it's compounded monthly or yearly or biannually or daily or whatever. You're going to use that. But when it's compounded continuously, this right here is the equation we're going to use. Alright, let's set this thing up like we did the other one. So it says find the future value. So again, that's the future value, the A. We don't know what it is. I'll put a little question mark here. The P is the principal. So the principal is how much money you're putting in the bank, which is $5,575. We don't really need the dollars right here. For 9 years, so that's the time. And 5%, that's our rate again. So it's 0.05. Compounded continuously, so we don't have the M there for the amount that's compounded. So we're just going to put it in this little formula right here. We need to know what this stuff means though. So it's going to be A equals P, which is 5575, times E. Now we've got to remember what E is. Let's put a parentheses here. So we're going to go E. Now you could just put 2.718, or you could put it in your calculator. You can actually put E in the calculator if we remember how to do that. We'll look at that in a second. And that's to the RT power. Alright, so let's go ahead and do this. Now, so actually I shouldn't have, what am I doing? I shouldn't have done the RT power. Let's actually put that in there. Well, the rate is 0.05 and the time is 9, so let's just put that in there. That's just going to be 0.45 if you want to just, I mean, you know, 9 times 5 is 45. Move the decimal 2 places to the left, so it's 0.45, or you could just put it in a calculator. It's just a little easier just to do that right off the bat. Now, a lot of people are tempted to multiply this one and this one together, but you can't because this thing in the parentheses is being taken to this exponent. So remember, order of operations. Please excuse my dear Aunt Sally. You have to do exponents before you do multiplication. So you have to take this 2.718, which is E, approximately E, to the 0.545 power. You have to do that first. Then you can take it and multiply it by 5575. So let's bring the calculator up again and let it load up here. Let's drag it so we can see it. Let's see, does it fit here? No, we'll put it over here. Turn it on. Let's clear all that junk. And let's do this. You could put E in the calculator if you would like. If you look right here, there's an E to the X button. So if you hit 1 and then second function and it's ln, that'll be an E to the X. Actually, you know what? I think I did that wrong. Again, I'm not really used to using these graphing calculators that much. It seems weird for me to say that, but I like the scientific calculators, to tell you the truth. So let's do this. Let's hit E to the, it's asking what power do you want to take this to? Well, let's just take it to the first power because we just want to find what E is, E to the first. And then we hit enter. Alright, so we're going to take that answer and we're going to take it to the 0.45 power. So take that answer, see that's going to take that 2.718281828 and it's going to take it to the 0.45 power. So take it to the 0.45, oops, let's go backwards. 4, okay, sometimes it doesn't click too well on here, and we hit enter and we get that number right there. So that's 2.718 to the 0.45 power. Then we got to take that answer and multiply it by the 5575. So we do that, multiply it by 5575. Alright, hit enter, and that's our answer right there. 8,743. Remember, this is dollars, so it's 34 cents. So 87.43, 87.43. And I think it was 34 cents if I remember right. That's how you do that one. Alright, let's move on. Alright, going on to number 8. Now they changed the question a little bit. It says find the present value of the future value. So we're trying to find the present value. The present value is how much we're actually right now in the present putting into the bank. So happens to be that it also starts with P, but that's the principal. It really doesn't stand for present, but you can think of it that way, I guess, if you like. That's the present value. So again, we're using this formula right here because it talks about compounded quarterly. It's not a continuously problem, so we're using this one up here. But this time, we're trying to find the present value. That's what we're searching for. On the other problem, they gave it to you, and we had to find the future value. This one, find the present value of the future value. So the future value is the A, right? And so that's what this number is right here. So the A is the 10,000. And 16%, that's the rate. Move the decimal, 0.16. Compounded quarterly. Quarterly, quarter means 4, so it happens every 4 months. This money, this $10,000, compounds. This interest is applied to it 4 times a year. So that's our M. Right? It's not how many months necessarily, it's how many times it compounds a year. 4 times a year for 10 years. T is 10. Alright, so let's start plugging stuff in and see what we get. You could just solve for P right away, I guess, but I think most of you figured that putting the numbers in might be a little easier for you, so let's just do it the way that you're more comfortable with. So we'll put it into this formula right here. So A, so which is 10,000, equals P, which we don't know, times 1 plus R over M, 0.16 over M, which is 4. Just following the equation, just plugging in numbers, plug and chug into the equation to the Tm power. Tell you what, let's just do this in our head. That's easy enough. 10 times 4, which is 40. That makes things just a little bit easier for us. And now we got to solve for P. You want to get that by itself, get rid of all the other stuff with it. Well, the easiest way to do that is just take all of this. All this is being multiplied by P, so just divide everything by all this mess right here. You could, I guess, just stick it in a calculator right now and get a number for it and then divide. I guess that would be alright. Wouldn't be that big of a deal. Or we could just do this. We could say P equals, watch, we're going to divide everything by 10,000, so just put 10,000 divided by all this stuff right here. Either way, whatever you're more comfortable with, it doesn't really make that much difference. To the 40. Alright, plug that into a calculator. Okay, just to save some time, I already did it, and there it is. It's 10,000 divided by, put a parentheses when you're going to put all this stuff in here, 1 plus 0.16 divided by 4 right there, close the parentheses, take that to the 40th power, so that up arrow caret thing is the exponent up to the 40th, hit enter, and there you go. It's 20, 82, 89. So it's his money again, right? So I shouldn't have to tell you how much to round it because it's money. So you round it to the cents. So it's 2082.89. That's how much money you put in, and that's how much money you get back after 16% interest for 10 years compounded quarterly. Alright, let's keep moving along. Number 9. This is probably the trickiest of all the rate problems. It says find the required annual interest rate. So that's what we're looking for, is the rate. Let me change a couple things here. I always forget to do that. Should have done that right at the beginning. Let's try that again. Find the interest rate. So that's what we're looking for. I always put R equals question mark for the thing I'm looking for. To the nearest tenth of a percent. So our answer has to be written as a percent. Some of you guys wrote the answer as a decimal, and I hated to do it, but I marked it wrong because it says specifically round to the nearest tenth of a percent. So you have to write your answer like that. Let's see what's going on. For this much money, $1,087 to grow to $1,743. And so this is what we start with, this is what we end with. So this is our principal, this is our amount. So let's write that down. Principal equals 1087. The amount is what it grows to, the future value, which is 1743. Alright, if the interest rate is compounded quarterly for 6 years. Compounded quarterly, we talked about that earlier, that's a 4 for 6 years. Time is 6. Alright, so let's, I tell you what, let's throw this stuff in. Looking at this equation right here, I'm going to just fill in everything. A, 1743, equals P, which is 1087, times 1 plus the rate over the M, which is, we don't know what the rate is, so we'll call it R, over M, which is 4. And we take that to the Tm power. T times M, just do that. 4 times 6 is 6 4s are 24. And there we go. Now what we're trying to do is we're trying to solve for r. So this is what we do quickly. Divided by 1087. Oops, that's a 10. Sorry, 87. That gets rid of this. Get rid of this 24th power. So we take the 24th root. Alright, that gets rid of that. Get rid of the 1. So I'm running out of time, so I paused it and just did this. So we subtract a 1. That gets rid of that. Now look, it's just r over 4. How do you get rid of the 4? You just take this whole thing and multiply it by 4. Plug it into the calculator and see what you get. Okay, I have to do this quickly. So it's the 24th root. You go to math. There's the root. You hit a 5. Let's see, hit the 5, there you go. And then you put 1743. I don't know if you need a parentheses or not. 1743 divided by 1087. I'm running out of time, so let me pause and put it in. Okay, I led you astray at first. You hit 24, then you hit math 5, hit this, and that's it.